Tutorial sheet 1, question 14. So we're given a function which is a discrete function y of n is equal to 3x of n plus x of n minus 2. And we're given an input x1 of n which is equal to 1, 1, 2 for n is equal to 0, n is equal to 1 and n is equal to 2, and it's 0 otherwise. So we're asked two questions here. First of all, obtain the impulse response. Well, this is relatively simple because we're already given an equation which describes the output as a form of the input. So what we're saying for the first part is that x of n is a delta, an impulse. So in this case, y of n, which is equal to our impulse response, h of n, is equal to 3 delta of n plus delta of n minus 2. The second part of the question says evaluate the response of the system to that input signal given there. Well, there are a couple of ways you could do this. You could use convolution, because now you have the impulse response. You could convolve that with this signal. A much simpler way to do this is just to split these two signals into their two separate parts. Because we know what the inputs are, we can just directly add them into here. So what we have, what I'm going to plot is n across the top, and we're going to have n from 0, 1, 2, 3, 4 and 5, and then we're going to have our two functions, 3x of n and x of n minus 2, and then the total, because we have to add them up, we can do that. So for 3x of n, well, when n is equal to 1, x1 of n is 1, so 1 times 3 is 3. Similarly, when n is equal to 1, x of n is 1, so that's 3 also. When n is equal to 2, we have a value of 2, so 2 times 3 is 6, and 0 for everywhere else. X of n minus 2, so the n minus 2 means that there's a shift in x of n, and so nothing's going to happen now until n is equal to 2. So when n is equal to 2, we just have our function x of n. So we're going to have 1, 1, 2, and 0 everywhere else. So now all we have to do, because we've got our individual functions, we can just simply add them together for all values of n. So we get 3, 3, 7, 1, 2, and 0 everywhere else.